Hi, this is just the review of the probability practice questions that I have posted under Chapter 4. So this probability practice does have a couple of review questions. If you recall that our exams, while they mostly cover whatever unit that we're working on, there will be some questions regarding those previous chapters. So it's always important to brush up on those. So here's the first one. Dr. Terry selects 6 particular students that he knows well to interview. This is an example of, and that would be a judgment sample. If you are picking particular people for your sample, then that automatically becomes a judgment sample. There's no probability involved. You are picking those individuals that you want. So another example of a judgment sample would be references or letters of recommendations. You are picking those particular people who you want to represent yourself. Chapter 2, so we collect data on race and ethnic groups and their income. So which graph would be used to best display the data? In this case, we have categorical variables, so that's going to be a bar chart. Histogram and stem and leaf are for numerical variables, and a contingency table is going to be for 2 categorical variables. So because we only have, just the race and ethnic groups, then we are going to just use the bar chart. From Chapter 3, the median home value in Pleasanton, California is $134,500 according to Zillow. If the distribution of home values is right skewed, then we should expect the mean home value to be. So this question addresses the relationship between mean, median, and mode for right skewed, left skewed, and normal distributions. So if we remember, with a normal distribution, how normal is that? We have our mean, median, and mode, and they're all right there in the middle. However, when we have a right skewed distribution, something that looks like that, we have values over here that are pulling that mean. So our mean is going to become closer to the tail here than our median. And if we have a left skewed distribution, so it kind of goes like this, we have some lower values over here pulling our mean towards the tail. There's our mean, and our median's probably right here. Okay, so in this case, we have a right skewed distribution. So right skewed, the tail's always going to be on the right. And it looks like our mean is greater than our median. So our median is 134.5, and we would expect our mean to be pulled towards that tail, so it should be greater than 134.5. So A is our answer here. Okay, Chapter 4. So Guillermo owns an appliance store that mainly sells refrigerators, but wants to know if it would be wise to continue to carry washers and dryers. The probability that a customer buys a fridge after walking into the store is 0.76, or 76%, and the probability that a customer buys a washer and dryer set after walking into the store is 0.4, or 40%. So what is the probability that a customer will buy both a fridge and a washer dryer set? These are both 2 independent events. So to get the probability of both occurring, we just have to multiply them together. So 0.676 is the probability that a customer buys a fridge, and 0.4 is the probability that a customer will buy a washer dryer. So multiplying those together, we get 0.304, or 30.4%. The probability that a customer buys a fridge is known as a simple event. That is one event occurring, so we're going to have a simple event. The probability that a customer buys a fridge and a washer dryer set is known as a joint event. We have 2 situations here, and we want to know the probability that they're both occurring, so that becomes a joint event. Which is more likely, a customer buying a fridge or a customer buying a washer dryer set? Well, if we go back up to our description here, the probability that a customer buys a fridge is 0.76, and the probability that a customer buys a washer dryer set is 0.4. So 0.76 is greater than 0.4, therefore a customer buying a fridge is more likely than buying a washer dryer. Guillermo wants to calculate the probability that a customer will buy a washer dryer set given that he or she has already purchased a fridge. So this is known as conditional probability. We are looking at something that's happened before and seeing what the probability is based on that. So we're looking at the probability that they've purchased a fridge, but that's dependent on if they bought a washer dryer set to begin with. So that becomes a conditional probability. Guillermo decides that he wants to use a new marketing campaign for washer dryer sets. The probability that a washer dryer set sells using the new marketing campaign is 0.7. If his initial probability of selling a washer dryer set is 0.4, and he wants to know what the probability would be if he uses the new marketing campaign, he should use Bayesian analysis. So Bayesian analysis has to do with the updating of probabilities. For the purposes of this class, we are not going to go through the equation and how to calculate it, but you should know that Bayesian analysis has to do with updating probabilities. Guillermo can fit 4 fridges in the display window. How many different ways can the fridges be ordered in the window? Okay, so the reason why this is a factorial is because say we have 4 different colors fridges. We have a green one, a red one, a blue one, and a purple one. Okay, so in our window we have 4 spaces, right? 2, 3, 4. In this first space, I can pick any 4 of these colors, right? So there I have 4 possibilities. When we move over to the next space, so let's say I picked red in this case. In this next space, we only have 3 options because the red is already over here. So we have green, blue, and purple we can pick from. So that gives me 3 options. In this next window, say I pick purple here. In this next window, we only have 2 options left because we've already had a red here and a purple here. So we have either a green or a blue. So I have 2 options. Let's say I pick the green one to be here. And the last one, obviously there's no other refrigerators left to put in the window except for the blue one, so I'll put the blue one right there. So the reason we calculate this using a factorial is for that reason. We have this many choices to begin with, and as we fill in these spots, it decreases. So in this case, it's just 4 times 3 times 2 times 1, and that equals 24. And the last one, a customer wants to buy a fridge, a washer, and a dryer. If Guillermo sells 100 different fridges, 15 washers, and 15 dryers, how many different possible combinations could the customer buy? So in this case, all we have to do is multiply these together. 100 times 15 times 15 is 22,500, and those are all the different combinations that we have. Just going on a smaller scale, why that we just multiply them together? Well, if we have, say, 3 refrigerators, 2 washers, and 2 dryers, we could do a red refrigerator, a purple washer, and a yellow dryer. We could also do a red refrigerator, a purple washer, and a pink dryer. We could also do a red refrigerator, a orange washer, and a yellow dryer. We could do a refrigerator, an orange, and a pink. So again, you're kind of just going through all of these different combinations, and that is why we just need to multiply them together.